On this week's episode of Motorhead Garage, Sam and Dave take a trip out west to the Golden State to tour the ARP manufacturing facility and to find out exactly how ARP's famous bolts and fasteners are made.
Welcome to Motorhead Garage, folks. We are down here in Southern California at ARP to pick up some of the latest information they got, but also see some of the latest products they got, too.
You know, the diesel market is just going wild. When you build power in a diesel, the cylinder heads want to lift off the block, they stretch the studs, they stretch the bolt. ARP's got a fix for that.
You better believe it. And I'll tell you what, you know, anytime you modify an engine, you got to do other things in order to accommodate that. That's why they've got these new studs here. And speaking of that, I want to show you how they make them, too.
All right, that sounds like a deal.
I'm out of here. You carry on, buddy.
All right, man.
Keep
I got
working.
lots to do. Besides having a stud kit, which takes care of the problem of the cylinder head lifting, blowing head gaskets, damaging the engine, they also have some nice dress-up stuff from ARP. Polished stainless 12-point fasteners all throughout the engine. Got them for the exhaust manifold. And of course the front, they got them in the back, and they have the business end too. You got the flywheel bolts. You got that big heavy flywheel, you got a lot of torque coming off that crankshaft. You want good fasteners, and ARP are the best. Okay, now, here's a 4-cylinder Cummins diesel. This is the small brother of this. It's basically the same as the 6-cylinder. It's got 4 cylinders in it. We're gonna work on this today. I'm gonna show you a couple of neat things. And while I'm going ahead and getting the instructions out and getting familiar with what we're doing, let's see what Davey's up to.
Okay, folks, this is the first step of the whole process. And we have Chris Raschke here, who's the sales manager. And Chris, what are you doing?
We're just checking some of the concentricity on some of the parts that are being cold forged right now.
Okay, now you talk about cold forming. That's what you have right here. These are these cold forming machines or header machines, right?
Yes, these are the progressive machines that take the wire, the cold coil, and they form the head of the part to start the bolt making process.
And it's a constant process of you make it, and you're checking to make sure it stays within specs all the time, right?
Yes, constant quality control throughout making the part.
Where do you go from here?
We go to the pointing and chamfering.
All right, let's go there. Okay, Chris, we're in a different section now. The pieces that come from the cold formers. Now, what are you looking at here?
Well, we have a rocker stud blank. And in this operation here, the operator's going to point and chamfer the end of the bolt. It's pretty critical the operation to do before we roll the threads.
All right, you roll the threads rather than cut threads, right?
We only roll threads, yes, sir.
Now, why is that?
It improves fatigue life. It makes a better part. It's a nicer way to go.
All right, so once that's chamfered, then where does this go?
This is going to go off to the heat treat.
All right, let's go there.
When you get your ARP cylinder head stud kit, read the instructions. Read them thoroughly. Do everything it says to do. When you want to make sure that you've got good thread insert, you're going to get proper torque specs, all those kind of things. Clean the threads. These are the thread chasers. These are not taps. They're not going to take any metal out. And you get these from ARP. They got the part numbers right in the instructions. This is a 12 by 1.75 millimeter thread. Just go in here, and by doing this, you get all the dirt and carbon, any debris that might be in the threads, and you can see it's going in pretty easy. These are pretty clean. You want to clean all the ones in the cylinder head, or in the block first, then in the cylinder head, wherever a stud screws in, and then we'll get this thing ready to install it. While I'm cleaning out all these, we'll read a little bit more of the instructions, and we'll see what Dave's up to.
Well, folks, we're in the heat treat section now, a whole other building here. And Chris, you've increased this a lot. Why?
Well, you know, we needed more capacity, so we doubled our capacity by adding another IQF, 2 more draw ovens, and a conveyor system to rack and get the parts ready to load into it. We've also computerized the system so that we can have a better control on how we do the heat treat process for the parts.
So when you talk about computerizing it, what else have you done with it?
It's touchscreen controls, and the owner of the company can watch the heat treat process from his office. It also puts the data, when it's complete, into our system, so we don't have to transfer data.
There you go, folks. I tell you what, they're keeping an eye on things. What's next?
Shot and sandblast.
Lead the way.
One of the things we have to do, following the instructions here, when we put the stud into the block, of course the head will be on, and the rocker arm stanchion goes on it, we're going to run interference with the valve cover. There's a little machine work you need to do. You need to take a little corner of this off. The dimensions are right here. It's very simple to do, particularly if you have a milling machine. I'm going to take these things here over and have them machine them out for me, according to the instructions. And let's take a look at these studs. These are awesome studs from ARP. They all have an Allen socket in the end of them. You get your Allen wrench, you run these things down till they bottom. Don't crank them down. They're supposed to be just finger tight. And of course, if they're going into a water jacket, you may want to put a little ARP sealer on them. And sometimes people want to put Loctite on them. If you use Loctite, you're going to have to really work fast because you got to get it torqued before they set up. You look at these studs, these things are beautiful. And everybody knows they're high quality, but there's more to making these than you think. So let's have Davey show us what it takes to make one of these studs.
This is the header machine that's making it. We got Christoph here who actually operates this machine. Chris, tell me how many studs this thing will make.
Well, in a day, we can make about 7,000 to 8,000 pieces, which is, we'll fill up one of these large bins and about half of another. Before, we were doing about 5,000 to 10,000 a week. Now we can accomplish that much in a day with this machine.
Well, you can see they pick up their production a lot on this thing. Of course, you're checking everything as this goes through. These are highly precision-made pieces.
It's a lot to watch out for to make sure everything is running good and every piece that comes out of this machine is usable.
Folks, we're going to take a short break. When we come back, we got a lot more here at ARP, so stick around. Go ahead, Dumper.
Welcome back. Now let me show you a rocker arm stanchions here. This is where we machined it out. You can see not much meat has to come off at all. That's to give us clearance when it's on top of the stud. Of course, the cylinder head will be in here. You're going to have the big nut up there. And that way you won't run interference on your valve cover. So I'll get rid of this for now. The other thing you want to do in this particular application, it's got a dimension, 6.615 to 6.665. Gives you a pretty good range. If you got a tall dial caliper like this, that'll work. This is 6.6440, right in the middle of the spec, so we're in pretty good shape. Check them all. If they're not right, fix it. I've got this block all cleaned out. I took some compressed air, blew everything off. Quality head gasket, put it on right and dry, nice and clean. Make sure your alignment dowels don't have any burrs on them. I'm going to clean up the cylinder head surface, pop the head on, and we can start installing the studs. While I'm doing that, let's check Davey out.
Okay, Chris, what goes on here?
This is our double chamfering machine. We built this machine where it'll grab the stud in the middle and hold it, and it'll come and chamfer both ends simultaneously. This gives the operator the opportunity to quality control and feed the machine.
Then what's next? Heat treating and then threading?
Heat treat, grind, and then thread roll.
All right.
One of the things you want to do when you put studs in or bolts, you don't want to put the threads in dry. ARP has their Ultra Torque Lube. It comes in the kit. Oh, you don't need much, okay? And put this in here. You want to have something on the threads. And again, this is just going to go down hand tight. They also have their Ultra Torque fastener assembly loop in a big can. It has a brush in the top. And if you notice, I put the cylinder head on, set it on the alignment dowels, then I put the studs in. Don't put your studs in and then try to wrestle the head off over it. Makes it hard for you. You get trash in the studs, really make a problem. So now I'm going to put my rocker arm assemblies on, and I'll show you exactly where to put this when we put the nuts on. All right, when you're using your ARP Ultra Torque, what you want to do is put some of this, not a lot, on the bottom of the nut and on the top of the washer. You've got it on the threads on the stud, the part of the washer that's going to meet the bottom of the nut. You want the bottom of the washer where it touches the stanchion, that can be dry. That way, you do this to all of them, you'll get good even clamping force when you torque it. We'll do all of these, and then we'll go ahead, take our specifications for torque, the pattern, and we'll go ahead and we'll torque it all down, make sure everything's right. While I'm doing these, let's check on Davey.
You know what, Sam, the amount of detail that goes into making these fasteners is incredible. Chris, we got two right here. Now, what process is this going through?
Well, this is going through shop peening. After the parts came out of heat treat, they have a scale on them. And what we want to do is we want to shop peen that scale off to get it good and clean so it doesn't contaminate our grinders and our thread rollers.
All right, so this is what comes out of the heat treat.
Yep.
And this is what it looks like after it goes through here. This is your shot right there.
Yeah, this is the steel 17 thousandths diameter steel shot that we use to clean the part.
And the reason for that is what?
Strictly to decontaminate the part from the scale so it doesn't contaminate our oil and our grinders and our thread rollers.
All right, we are over here now in the polishing and deburring section.
This part has already been heat treated, it's been pointed and chamfered, and now it's coming over just to get some tumble deburr work done to it to smooth it out and get some finish work before it gets ground and rolled.
All right, and then you also have some stuff that are being finished as well.
Yeah, this bolt here is one of our high-strength stainless bolts. It's here for its final polish.
Okay, Sam.
Our next step is torquing all the fasteners. Now, Use your ultra torque assembly lube. Make sure you put plenty on, you know, not gobs so it's hanging off the motor, but you don't want to be stingy with it, particularly on the threads. We have our bolt torque sequence, and it's a pretty standard center out sequence. And the other thing is, it calls for these 12mm studs to be 125 foot-pounds. You want to do that in 3 equal steps. We'll start off about 45 foot-pounds, run up to about 75, 80, and then finish it at 125. And again, following the pattern. And while I'm doing this, we'll go over and see what old Davey's up to.
All right, well, we're in another building here at ARP. And Chris, this is where you do the kind of the final finishing in it.
Yeah, some of our parts are black oxide coated. So here we have a finished part, and it's had all the heat treat, the grinds, the rolls, the broaches. Everything's done, but now it's going to come in and get black oxided.
Okay, and then from here it goes in a box and out to the customer, right? Hey, welcome back to Motorhead Garage. We're here at ARP learning how they make these wonderful fasteners. Now, Chris, we've seen a lot. What are you doing here? You say you have to straighten it?
Yeah, after you heat treat the stud, sometimes it'll warp a little bit in the oven. So what we do here is we take and we press it between two flat dies. We squeeze it down about 4/1000ths of an inch, and that gets it straight enough to go into our centerless grinders.
Okay, now you talk about grinders. Where are they?
They're off the other side here.
All right, let's go. So Chris, this is what, the grinding area, right?
Yeah, we do. We have 29 centerless grinders here at ARP. 7 of them are computerized.
Now, you know, you guys are growing so fast. You got lots more customers. How do you stay up with the demand, and also how do you keep the quality control when you increase your production?
Well, one of the ways we've done that is with these CNC grinders, it allows the operator to place the part and feed the machine. The part will come off the other side of the machine, but it gives them time to do the quality control in between each part. So we're not taking the operator out of the picture. We're allowing that operator to do more QC while the part is being ground. We can do several grinds with this with very good repeatability, because that's the part that you program the computer for.
Whereas before, you want to do a different grind, you'd have to go to different stations. So this is how you're increasing your production.
Correct. All right, now, these engines have individual valve covers. Here's the stock valve cover. Don't even have a gasket on it. And you can see it settles right down on the head. You've got clearance from here. You don't need to modify these. Once you cut these rocker arm stanchions, you have no additional modifications. I got all the covers in the wash tank, cleaning up. I'm going to get a gasket for each one of them. And then I'll go ahead and I'll adjust the valves, put the cover and gaskets on, tighten those down. ARP also has some beautiful stainless steel fasteners for the front cover, all kinds of places in the engine. But here's what you want to do. The factory bolts are not really strong. When you talk about a balancer, particularly where these guys race, they will drop these balancers. The bolts will come out, the bolts will break. ARP makes good bolts for the balancer. Put them in and torque them. This particular setup torques to 90 foot-pounds. You want to make sure you get them all torqued. Nice crisscross pattern. And every time you do it, put new bolts in. All right, I'm going to go ahead and start cleaning these valve covers up, get everything ready. While I'm doing that, let's see what Davey's up to.
Sam, I got Mike Wholesale here, who is the president of ARP. And Mike, what are we doing here?
This process, we call it Phillip Rolling. He's actually taking the part and putting it between 3 dies that match the radius under the head. And what that accomplishes is it squeezes under the head, same way with Phillip Rolling. It actually distorts the material a little bit, and it compresses the micrograins under there and gives us a lot of fatigue life. Otherwise, the head would come off if he wasn't doing this.
So there you understand what it takes to make these things the way they are, why you have such high quality in it. Sam?
You know, ARP got all these stainless steel dress-up fasteners. They go everywhere. Valve cover. They even have bolts if you have a aftermarket exhaust manifold. They got it covered. And you know, these things are not only pretty, but the ARP stainless steel fasteners are 25% stronger than grade 8. And you know, using that stud kit like we put on this 4-cylinder, they solve problems. When we get back, I'm going to show you another ARP fastener that'll solve the problem that almost everybody has. Right now, let's check Davey out.
Well, Sam, we're over here at the thread rolling area. And Mike, why do you roll your threads on it? What's the big difference between that and cutting threads?
Well, when you're rolling a thread, you're compressing the material. And being we roll threads after heat treat, the compressive stress is a big plus for us. It increases the strength in the threaded area. It increases the fatigue strength. No materials lost. You can see that we start with a smaller diameter roll, and it actually just raises the material up. The finish is much better. I mean, it's a micro-polished finish by the time the dies are done with it in there. As they roll it, they're also polishing the radius, and it's a controlled root radius in the thread also. Gets the right torque, gets the right fatigue we need, and the right tensile strength also. It has to do with that.
All right, hey folks, we're going to take a short break. Stay with us. We'll be right back. Hey, welcome back. We're here at ARP, and we're here in their Quality Control Center with Mike Wholesale, who's the president, and he's also very much of a hands-on guy here. Now, Mike, we hear this hum going on. What are you testing right now?
This is the fatigue, the Amsler fatigue machine, and what this does is pull apart and release it. For instance, this part's being pulled about 10,000 pounds and releasing it to about 1,000 pounds, and doing that about 8,000 times a minute. Your compressive stresses in the thread are holding it together, and the compressive stresses under the head are holding the head on. So that's why those operations are very important.
So in other words, you're taking that, what is this, a rod bolt in there?
Yeah, it's a connecting rod bolt.
Connecting rod bolt, and in effect, pulling it back and forth, very similar to the way it would be in a regular engine, right?
Yeah, yeah. This is, in a way, duplicating that and giving us an idea how much fatigue life we're going to get out of a part.
That's how you keep them from breaking.
We got something here that's going to help you guys out with small block, big block Chevys. You know, starter noise. You hear these guys engage the starter, it hits the ring gear, it sings and grinds, makes all kinds of noise. Even if you took the time to shim it properly, get it in place, they move around. Especially if you didn't use the knurled starter bolts, use just a 3/8 24 bolt. Now, we have a fix for this, but let's listen to the noise this one makes. I got the ignition distributor disabled. Go ahead, bud, give this a crank. Every time you hear that noise, besides being an obnoxious noise, you're working on your ring gear and your flywheel. ARP has come up with a set of bolts that do a great job. This is what the end of your starter housing looks like. And these bolts, they have a double step knurl on them. Okay, they go in here. When it goes in, it actually bites into the top of the starter housing here, and it positions it in the block. The same thing with the shorter bolt. You still need to make sure you set up your pinion depth from the starter drive. Once you put them in, bolt it up, tighten it down. Starter's not going to move, cures a lot of problems, gives you a better ground, does a whole bunch of stuff for you. You don't need to over torque these. Starter's tight. All I did was put in the ARP starter bolts. All right, buddy, let's hear what this thing sounds like. Again. Thank you. Quiet as can be. I'm going to go ahead and clean up here. Let's check Davey out.
All right, Sam, we're still here in the QC lab. We're doing a tensile test right there. Tell me about that, Mike.
Well, a tensile test, what that's going to do is confirm the heat treat process. It'll also confirm the thread rolling process and the design of the bolt.
So you're really just trying to pull that apart and see
Pull that apart and get the ultimate strength of the part.
There you have it, folks. Chris, what is this deal here?
This is our new laser lab. This machine will, via laser, will measure 100% of the aspects of the parts and print out the data for us.
And once you get all that information, it just goes right into your system then, doesn't it? So
Yeah, but it saves us a lot of time.
I can believe that. And that way you can run a lot of parts through and do a lot of quality control in this thing, faster than the old way.
Yep.
Hey, come here, bud.
Getting ready to adjust the valves there, pal. What do you think?
Hey, you're looking pretty good. You know, folks, we're running out of time, but we want to thank the guys here at ARP for letting us come in here and see what they're doing, and for them for showing us around. We'll see you next week here at Motorhead Garage.
So long. We need to turn this motor,
Yeah.
but I got these little studs back here.
Oh, I see.
Well, I had to torque the bolts here.
That's what you did to hold that thing?
Yeah.